Every message you send, every video you watch, every bank transfer, map search, cloud file, and AI question, all of it depends on a system most people never think about. The internet feels like it was built for us, but it wasn't. In the 1960s, computers were not personal. They were massive, expensive machines locked inside universities, research labs, and government-funded institutions. Only a small number of people could use them, and even fewer could connect them together. The question was not, how do we build social media? It was not, how do we stream movies? The question was simpler and far more serious. How do powerful computers in different places communicate with each other? And how do you build a network that can survive if part of it fails? The project became known as ARPANET. It was funded by ARPA, the Advanced Research Projects Agency connected to the United States Department of Defense. But it was built through universities, researchers, and engineers, not as a public product, not as entertainment, but as an experiment in communication. In 1969, researchers tried to send one simple word across this early network: login. But the system crashed after only 2 letters: L-O. A broken message became the beginning of a network that would later reshape the planet. The key idea was packet switching. Instead of sending information as one complete block, the message could be broken into small pieces. Each piece could travel through the network separately. If one path failed, the data could find another way. This made the network different from older communication systems. It did not depend on one perfect road. It could adapt. It could route around damage. It could keep moving. The internet was not born as one cable. It was born as a new way of thinking. But ARPANET was not enough. Different networks began to appear. Different machines, different systems, different rules. To become something larger, they needed a common language. That language would become TCP/IP. TCP/IP gave networks a shared rulebook. It allowed different computers and different networks to exchange data. On January 1st, 1983, ARPANET officially adopted TCP/IP. That moment is often treated as one of the birth points of the modern internet. But even then, ordinary people were still not the audience. There were no influencers, no streaming platforms, no online stores, no smartphones, no search engines as we know them. The foundation was there, but the network was still mostly hidden inside research, universities, and technical communities. It was powerful, but not yet human. The real transformation came later. The World Wide Web made the internet easier to use. The web was not the same thing as the internet. The internet was the infrastructure. The web was the layer that made information clickable, searchable, and human. Once the web arrived, the network stopped being only a technical system. It became a public space for information, communication, business, and daily life. What began as a research tool slowly became the digital world itself. And now, artificial intelligence is growing on top of that same invisible engine. AI models are trained on internet-scale data. They run in data centers connected by global networks. They answer questions, write code, generate images, and automate work. The internet made information global. AI may make intelligence feel global. But every invisible engine has a cost. The same system that gives us knowledge also tracks us. The same network that connects us can distract us. The same infrastructure that gives creators power can also concentrate power in the hands of a few companies. The internet changed the world, but it also made the world dependent on systems most people barely understand. The internet did not begin as a social network. It did not begin as a marketplace. It did not begin as entertainment. It began as a technical experiment, a way for machines to communicate. But once the machines connected, people followed, then companies, then money, then power. And now, AI. This is the invisible engine. Subscribe to understand the hidden systems behind technology, artificial intelligence, and the future they are quietly building around us.